Hi everyone! In this video I will show you two quick and simple methods of mixed PCB assembling. To the printed circuit boards I will install surface mount components SMD using bottom preheating table and manual soldering of DIP through-hole components. But the most important at the end, where I will show you one of serious mistake made by many electronic PCB assemblers, which leads to corrosion on the solder joints of DIP components. So I have a printed circuit board that includes surface mount SMD components and through-hole DIP components. This process is called mixed assembly technology. In modern electronic manufacturing, to reduce production costs and assembling time, it's better if you or your developers redesign the PCB layout to minimize manual assembly and soldering of DIP components, even though machines for insertion DIP components do exist. For placing SMD components, I use stannum 62, plumbum 36, argentum 2% solder paste in syringe with a no-clean roll zero flux. I carefully apply the solder paste only to the pads of SMD components for fast reflow later. Then I manually place the SMD components on solder paste, following the orientation marks on the PCB or assembly blueprint. Always observe components polarity if it's indicated on both the SMD parts and the PCB. Before assembling, make sure that the polarity marking keys on the PCB and the blueprints match. There have been cases when seal screen or blueprint markings were incorrect. In the best case, nothing will happen. In the worst, components may burn out due to reversed polarity. I will reflow the solder paste using a bottom infrared preheating table, placing the PCB directly on the hot surface or to the holders. Always use proper ventilation when soldering. Don't breathe those fumes. I set the preheating temperature 200 degrees of the Celsius, since the melting point of leaded solder is 183 degrees of the Celsius. A set temperature of 200 degrees of the Celsius is more than enough. Don't place the PCB early because the preheating surface warms up slowly and you can damage the PCB laminate. Long exposure to heat may cause delamination of the FR-4 PCB material due to overheating. In a professional reflow oven, the PCB heats up and reflows according to the defined thermal profile in about 4-5 minutes. A bottom preheating table warms up much slower and can cause the PCB substrate to blister or warp if exposed too long. In my case, I will place the PCB on the hot surface or holders only for a short time and nothing will happen to it. This approach is suitable for one-time jobs, when you don't have even a single zone reflow oven with proper reflow profile. It's a cost-effective method for occasional work. Now I carefully place the PCB to hot surface or holders. You can clearly see the solder paste melting. I really enjoy this moment. Then I remove the PCB carefully so the SMD components don't shift. Be careful not to burn your hands. Now I insert the DIP components into their position and bend the leads on the opposite side, so the components stay in place during soldering. I install all DIP components this way for faster soldering later. Also, pay attention to the polarity of DIP components and double check it with assembly blueprint and seal screen on the PCB. All components are now placed. Next, I apply soldering flux to the through holes of the PCB and leads, but not to all of them. Some people prefer liquid flux with a brush. I use diamond flux FN232 no clean roll 0 class. Others prefer gel flux. I use diamond flux FN231 in a syringe, also no clean roll 0 class. You will find links to these soldering fluxes in the description. It's also possible not to apply any additional soldering flux to the leads at all and use the dry flux that's already inside the cord solder wire. But sometimes its wetting ability is insufficient. It's still a very convenient method for soldering deep component leads. THT stands for Through-hole technology, which is the assembly method used for leaded deep components. The term deep describes the component package dual inline package, meaning the component has two parallel rows of leads designed to be inserted into holes. A deep component is a type of component that is assembled using THT technology. I start soldering them with a soldering iron at 320 degrees of Celsius. I heat the lead and the via with the soldering iron tip and feed Stanum 63 Plumbum 37 solder wire. And now we are getting closer to that common mistakes I mentioned at the beginning. Now I will show you a clear example. On one half of the PCB I will resolder the cut leads so they are tinned. On the other half, I will leave them as is, just cut. Okay, now I'm cleaning the PCB using Flux Off. In large-scale electronics production, water-based cleaning machines are used. They are more efficient and washing PCB much faster. Flux Off, however, is not water-based. Printed circuit boards operates under various environmental conditions, from salt mists near oceans and seas to morning water condensation. To simulate such conditions, I prepared a water mix, half teaspoon of salt per glass of water. I rapidly wet and dry all soldered deep joints on the PCB. I don't power the device on, there is no need for that right now. Multiple cycles of applying and drying the salt water effectively simulate typical operating conditions from humid environments or non-sealed enclosures, as well as temperature fluctuations from cold to warm, such as in the morning when moisture condensation occurs. Why am I showing this? Look what's happened. The part of deep component leads that I additionally soldered remained clean and undamaged. Yes, there is an oxide film on the metal, but there is no corrosion. Now look at the deep component joint that were simply cut off. The cut and exposed leads of deep components have become corroded. After soldering, I cut all the leads, exposing the base metals. After salt water test, the leads that contained iron or iron-based alloys in their core were covered in rust, but not all of them. The leads that don't contain iron alloys remain free from corrosion. Deep components leads metals are typically copper, aluminum, steel, brass, bronze or iron-nickel alloy. Guessing which one you have can be quite challenging. Internally, these leads may have a nickel layer to bond the base metals to the finish coating. On the outside there is a finish coating, usually the lead-free alloy, which makes soldering deep components easy for us. It's almost impossible and pointless to determine the base metal from datasheets. They usually specify only the finish coating layer, so if you don't want to lead to rust, after cutting them, always resolder cut-off leads to seal the base metal from corrosion. What can this cause for your device? Corrosion slowly eats away the metal leads between internal layers, gradually destroying the connection. This can lead to device failure and serious problems for your customers. If it happened electronics manufacturer, you definitely don't want to deliver corroded PCB to the customer. You will have to spend extra time and money for resoldering and cleaning again. The best way, resolder the leads immediately after cutting. Like this video and subscribe to the channel. Write in the comments whether you have encountered this issue and how useful this video was. In description you'll find links to my Instagram and Telegram. You can support this channel on Patreon. I also offer consulting services for electronics manufacturing, helping companies solve soldering and process issues. Thank you for watching. See you next video.